Okay, good afternoon. I'm Mike Coyazzo. I'll be hosting today's Life Safety Damper webinar on the topic of ceiling radiation fire dampers. So we're glad you were able to join us on our Wednesday webinar discussion. Ceiling radiation dampers are actually one of the most misapplied products that we sell, and so we feel it's necessary just to kind of go over this product type and just kind of cover all the essential areas just to make sure that everyone's aware of what the code requires, how the dampers are tested, what we mean by horizontal assemblies, the installation requirements, and also I'll cover a few misapplications that are fairly common. So these will be our discussion points for today. So first, let's talk a little bit about the codes and standards, right? We know that Chapter 7 of the Building Code, NFPA, as well as the Mechanical Code, they clearly call out membrane penetrations dealing with ceiling fire dampers. A lot of times there's confusion on that type of a damper versus a standard UL 555 fire damper product. So we'll try to kind of cross compare just to make sure everybody's clear on when to use it or when to explore another alternative. So for the UL test standards, I'm showing 3 of the test standards, but the UL 555C is the one that deals with ceiling radiation dampers. Oftentimes we hear the term ceiling fire damper or radiation damper. So you may be familiar with the radiation damper term, but they both mean the same thing. So these next few slides are actually from a floor ceiling assembly fire test. This was actually a wood joist type system. You can see in the photo there, we're showing to the right, we have our model CFD7. This is geared for 2x10 and 2x12 wood joist floor systems. So what you see off to the left, obviously, is the radiation damper that's installed. This is at UL test facility. So they're testing a full-scale floor assembly. So down below, what you're looking at is the furnace. That's where they generate the heat. So our radiation damper in this application, as you can see from the photo, we have to cover it with a blanket material. So there's a steel plenum box with the blanket material that's required as part of the application. Obviously, we show half of the blanket just for clarity that there is a plenum box underneath. So one side reflects the blanket, how it's attached to the box, and the right side just shows just a steel box. So in the field, this can be applied either by the contractor or we can supply the box and the blanket from the factory. So it's an either or. So what you're looking at here, this is actually the after effects of the fire test. So this image right here is showing obviously that the drywall has burned away. You can see the charring on the wood joist members. So there's the before, there's the after. So this particular assembly, and this will be common for most of your wood roof ceiling assemblies and your floor ceiling assemblies, right? So wood construction is typically limited to a 1-hour rating. So this CFD7 model is going to be limited to the same 1-hour rating that the assembly was tested and qualified for. So if you're looking at the product data submittal sheet and or the installation instruction sheet, you're going to see the reference to the 1-hour rating. On the physical product, the damper label, the UL listing label, won't actually reflect the 1-hour rating. It simply states ceiling damper. The way this works in the world of UL is ceiling radiation dampers are only qualified to the extent that the ceiling they're being applied in is qualified. So if I have a steel joist suspended floor ceiling system that's 2 or 3 hour rating, then the radiation damper being applied also takes on the same 2 or 3 hour rating. So whichever the case. So that's a physical fire test. Those are the results of it. And out of this test, we qualified our CFD7 model. We also have another model that's a CFD7T. The T is designated for the wood truss design, meaning 2x4 open web truss. So as a result of this fire test, we established a design number. Obviously, there's in the world of UL, there's test dollars. Obviously, you get a quote to test the product. Once you qualify, you get a design number. So you can see at the top there, it's reflected as design number L501. This is just an example. There's many of these in the UL directory, and you can see here by the illustration, they're going to depict a section view of the floor ceiling system, and you can see there the highlighted ceiling damper and then the company name. Obviously, in this case, it's a Ruskin model CFD7. Do keep in mind that there's designs that include multiple damper manufacturers. Those typically are going to be designs that the gypsum companies have qualified, and damper companies simply submit to be on that particular design. So just to make sure everybody's clear on the performance of the radiation dampers, ceiling fire dampers, as shown here in this illustration, are actually able to resist or limit the amount of radiant heat that's going to normally go through your air duct openings. As we can imagine, in a fire event, heat rises and the heat's going to transfer very quickly through that assembly if there's nothing to stop it. So the radiation damper is essentially limiting the amount of radiant heat that's going to pass through there to try to control essentially the heat level that's going to escalate within that cavity space. So radiation dampers are typically going to be a higher performing damper than your traditional UL 555 curtain type or multi-blade type. A normal curtain fire damper just has steel blades, so there's no radiation protection that limits the amount of heat that transfers through. So if I were to put a curtain damper in this application, it would obviously violate the code requirement, but it would also not be able to limit the transfer of heat through there. So your ceiling is going to collapse much faster than it would with the proper radiation type damper. So we're limiting heat transfer, so it's maintaining the ceiling rating. So again, going back to the way these get qualified, if I have a 1 hour rating, this ceiling radiation damper also takes on the same 1 hour rating. So it's able to maintain that assembly rating as if it were just a solid structure without any air duct openings. So in theory, that's all the damper's doing, is just maintaining the rated assembly when it's tested with no air duct openings. So as I said earlier, the UL sticker will just reflect ceiling dampers, and so we can go from 1 to 4 hours depending on roof assembly or floor assembly type. Your wood construction is usually limited to 1 hour, and a non-combustible floor ceiling systems made up of steel joists or metal decking and concrete upper cord is usually going to range from an hour up to 4 hours depending on the components that are in that assembly. You can see there by the photos, we have radiation dampers available in a true round, also in square rectangular sizes. Size is going to be important because every UL ceiling design is going to have limitations on the opening, the allowed opening area, per a given space. So typically it's going to read like 324 inches, square inches per every 100 square feet of ceiling space. So that's the one important thing that all designs are going to note, is the allowed opening space. So let's switch over to the building codes, right? So if we go into Chapter 7 and we look at the section that deals with horizontal assemblies, by the way, that's referring to your floor ceiling systems and roof ceiling systems, it really deals with two types of applications. It deals with through penetrations, and then it also deals with membrane penetrations. This can be a little tricky because a through penetration can refer to a typical fire damper. So again, we're talking about a horizontal floor system where a traditional curtain type fire damper could be applied, versus the membrane penetration where only a ceiling fire damper would be applied. So let's look at, on the next couple slides here, we'll take a look at how that actually translates for our applications. So here's two examples. The top one showing a roof ceiling assembly. It's a pitch roof design known as P523, just as an example. And below it would be a floor ceiling system. Obviously, we see the concrete slab on top, and then it's made up of steel members that hold up that floor assembly. So in both of these cases, the entire top to bottom, from bottom membrane to upper cord, that makes up the entire rated assembly. So it's not the bottom level by itself, it's not the top, it's the entire makeup. So here's my example where by code, as long as I don't go above 2 stories, I can legally use a curtain fire damper at the floor line, which is depicted there on the right-hand side. So there's my floor line. It's made up of a concrete. There's a thickness there. So we have a fire damper, traditional UL 555 damper in the floor line. And because I also have an air duct opening at the lower membrane, that's where I apply my ceiling radiation damper. So I could legally get away with 2 damper products, the fire damper at the upper floor level, and then a radiation damper at the lower membrane on the air device. So this is known as a through penetration. So visually, this is what the code refers to when it talks about through penetrations. This can only happen in non-combustible floor ceiling assemblies and also limited to 2 stories. So this may not be an application that you're actually able to accomplish. Had this been a wood floor structure, none of this could happen. So if I have a through penetration through any wood floor structure, a rated shaft is then the requirement. So there's no damper products that can fully protect through penetrations in wood floor assemblies. So here we're looking at a typical, sort of a by the book ceiling radiation damper application. So this is our by code membrane penetration. So we see a unit down below, ducted up, penetrating through that lower drywall. In this case, this would normally be like a hard lid ceiling. So we have a drywall ceiling penetrating through that. I can now apply the radiation damper at that lower membrane. There's no grill, there's no air device. It's simply ducted down to the connecting duct off that unit. Now you notice that the duct is just running parallel in the cavity space. It's not ducted up through that upper cord, which if that were the case, then a rated shaft would be required and the ceiling radiation damper would basically go away. Actually, any damper type would go away. So because my duct runs, like I said, parallel within the ceiling space, as I duct off or as I terminate at other air devices, radiation dampers are protecting all of those openings. So if you think about this, you've now protected every air duct opening that's coming through that drywall. So this is a proper, how it should be done application for your radiation dampers. However, there's going to be times when a rated shaft is the required construction feature. So a damper would no longer be sufficient to protect through your wood floor ceiling systems. So if you imagine a apartment, a condo, wood construction, they have multiple floors, 3 or 4 floors. Once you penetrate vertically up through those floor assemblies, a rated shaft by code is the typical mandate. So now let's just move over to what the 3 common ceiling applications are. So what you're looking at here are the 3 applications that your ceiling radiation dampers would fall into. So in the middle, we see surface mount. That's going to be a grill mounted application. What's happening there is the damper, the air duct opening essentially matches the grill size and the damper size. So you have full coverage. The damper blades will cover that complete opening. So that's a surface mount application. Then down below it, we have ducted below, no grill. That would be the example back here. So this is that example of the ducted below. So as you can see, there's no grill. You're going to have an extension piece that'll drop below the drywall ceiling and you'll connect to duct down below. Then to the far right, we have a lay-in ceiling application. The lay-in ceiling applications across the industry, this is going to be a shared or universal application. Any of the suspended floor ceiling systems that are non-combustible and that also use the old hinge door damper, all those applications now are allowed to have what we would consider the current butterfly design, a radiation damper, the typical ones that are on the market. All of those can be applied equally. So if you go in the UL directory and you find a suspended floor ceiling system, the lay-in type, if you see a damper depicted there, then these ceiling radiation dampers, what I would consider the standard type, can be applied on any of those particular designs. None of those will be wood construction. It's all made up of steel joist, concrete, steel decking, that type. So let's talk about where some of the problems happen, right? So a lot of times we get a call where somebody's trying to figure out what ceiling damper type they can use for a particular assembly, whether it's a roof assembly, floor assembly, whatever the case. Usually there should be architectural drawings for that structure that either detail or have illustrations or notes or something that calls out what type of ceiling design, roof design is specified. In this case, you can see in the blow up there, this is a design called P527. So the architect chose to use this particular design for this structure. So just keep in mind, anytime you're dealing with an application, it's always good to look on the architectural plans. That'll be the first question that we ask, is usually what ceiling design is being used or specified. And as I go to these next few slides, I just want to explain how we look these up. So if you give me a UL design number, what we're going to do is we go to UL's website, just ul.com. If you scroll down to the bottom of their page, which is shown in step 1, you'll see what's called the online certifications directory. So step 2 is just simply plugging in that design number where it says UL file number. And step 3 will produce essentially that design, because you're going to click on a link and it opens up. And so what you see there is design P527. So if I were on the phone with you and I get that design number, I'm going to plug that in, look it up, see what the design is, what the rating is, see what the notes say. Now, you'll notice in this particular illustration, there's no air duct shown. There's no light fixtures, no air duct openings, no damper shown. So in reality, this design has not been evaluated with air duct openings. So this will be a case where the authority having jurisdiction, fire marshal, whoever holds that position, will have to make a determination on if they're going to allow an opening in there, for an air duct, and or what product type they'll use. So this example is one where nothing's been evaluated, it's never been tested for any air duct openings, and authorities having jurisdictions will decide how to handle that. And I'll give you some other examples of how that may work as we go along. So this right here is the example that I just mentioned, where it's universal to the damper industry. This is just one example of a design. It's G250. So the G250, if you look at item 8 or 9, item 9 is actually the damper. This is an old style hinge door that had a 16 gauge sheet metal with a ceramic fiber material on the metal. So that was basically an original design for a radiation damper. So to the right, our current design was tested against the hinge door and proved to be equal in performance. So any of these designs that have the hinge door can utilize a current ceiling fire damper, and that's industry-wide. Okay, let's talk about wood construction. Wood construction should always raise a red flag because that's where we see the most confusion and misapplications. So what you're seeing on the screen now is a 2x4 open web truss design. There's multiple ones in the UL directory, the Gypsum Association. Most gypsum companies are going to have their own either generic designs or designs that were actually submitted for testing, and so they take on a UL design number. So what you're seeing there to the left and the right is our true round version. That's a round damper that's able to be applied in the wood truss application. In the middle, obviously a square rectangular damper model for the same application. One thing that's different on the installation is that these wood applications usually will have angles that get fastened to the wood members, opposed to the hinge door design where everything was hung with steel wire. So you have a hanging method of installation versus a direct attachment of steel angles to the wood. So the damper is essentially held in place by fasteners that go through the angles and into the frame. And this is done on the application installation is the same for the grill or ducted below setup. This here is going to be a wood joist design. So anytime we refer to wood joist, we're talking about 2x10 or 2x12 wood joists. We're not talking about I-joist floor systems. I-joist floor systems are different in their construction and how the attachment is done, which I'll get to an example of a misapplication. But we have wood truss here, 2x4 open web truss, and then we have wood joist. One thing that should stand out right away is when you have a wood joist system, you're limited on the height. So your collar connections only can come out of the side of the plenum box. So if you were to tell me you had a wood joist ceiling, but you're trying to put a round collar on the top, I know that can't physically work out because you're not going to have the height to put a collar tab on the top side. So sometimes just by virtue of what you're trying to do with the arrangement, tells us a little bit about what type of floor ceiling system that you may have. So I want to talk through this application scenario. This is an actual real example of how things happen in real life, okay? So what you're looking at here, to the left, you can see there's architects in Texas, Austin, Texas, that are designing out of state in Knoxville, Tennessee. This is a assisted living center. So in this particular case, the architect has chosen two roof and floor ceiling designs that are owned by basically a damper company. So what happens here, the question we get, as you can see, the exchange there at the top. So they're essentially asking if we offer a damper that's in compliance with both of these roof and floor ceiling systems. And if not, then which two models would we recommend for it? So to the right is our damper model CFD7T. So the CFD7T has also been tested in assemblies that are just like this P522 and L550. But when a damper company does a test, gets a UL design number, only their product name will be mentioned or noted in the design. So in this particular case, the confusion is that on paper, you're going to see one company. However, the architect specifying this design doesn't necessarily know that they've created sort of a nuance now, because any other products that are being acquired or presented for application here could be rejected by a plan reviewer who's looking at the notes in the design and finds out that it's a different company who has the damper for this particular design. Or they can look at another design that's nearly identical to it and understand that that design is not a damper owned design, and it has multiple damper products, because usually that's going to be a gypsum owned design, which is open to multiple damper companies. They don't limit any one particular product. So again, this is where it gets a little confusing, because depending on their understanding and how they decide to handle this, they may allow a substitution. The architects may get called to figure out if they can, allow a different substitute design in place of this, or if somebody wants to, switch and allow a substitute. This is where there's no one answer that's going to suit all situations. It gets a little more circumstantial. It just may depend on if the architects are open to that suggestion, if the code official is going to decide either way. So this is where we get a lot of calls, because we can't sort this out in one easy way. We have to first understand what designs are being used, who's going to make a decision. So this is where a lot of our calls stem from, is this type of a dilemma. So let me move on to part two of this application scenario. So if I were to try to just help someone understand how to decide this or how to evaluate this, I would basically pull up a gypsum owned design. In this case, it's going to be the one on the left, P545. This is a design owned by the gypsum companies. However, if you look at the design to the right, the P522, which is what's specified for this assisted living center, they're essentially identical designs. They just have two different numbers. So here would be a case where a code official, fire marshal, whomever, could decide that these two designs are essentially the same. If we allow, the damper in P522, it basically is allowed also in P545. So it's sort of a cross comparison between two of the same type of things. One has, again, a limited product offering because it's singled out to one damper company. But this is sort of the way we try to present information to authorities having jurisdiction, so they can understand what they're really looking at or what judgment they're trying to make. It doesn't mean they're going to be convinced and allow it. They may just stick to what's on the plans. They may just have a further discussion to find out if, we can substitute P545, since it's basically you're building the same thing, and then other damper companies' products could be included. So this is sort of how these conversations go. But I just want to point out, if you pull up these designs, you're going to see that they're nearly identical in every aspect. So let's talk about some misapplications, okay? Because there's certainly enough of those to go around. Around the country, we see a lot of the same problems occurring. This misapplication here has to do with the wrong damper type trying to be used where a radiation damper should be applied. So this L550 design clearly shows a damper, which is item 4. So that's the radiation damper. However, a contractor, even an engineer, it could be, just however it happens to go down, may have either specified, a traditional curtain fire damper. Contractor may have just ordered that, just assuming fire damper means, fire damper either way. So we're Xing this out because a curtain damper cannot be applied in this application, period. Industry-wide, nobody has a curtain fire damper approved in a wood floor. This is wood floor, by the way, a wood floor assembly. So this would be a misapplication. So this is something we're trying to help people not get into. So UL 555 fire dampers are not listed. The code talks about, install per the dampers listing. So this would not be listed for the wood floor installation. So misapplication number 2. So again, this is another case where, we have someone trying to apply the wrong damper into a situation. Now there's a couple things going on here that end up being a little bit more problematic. So this is a real sketch, right, that we received. So what they're telling us is it's all wood construction. We got 2 floors here. They want to put a curtain damper in both of these openings. So we have a full vertical through penetration. So this would be a classic rated shaft requirement. Why? Because you have 2 floors, built in wood construction being penetrated. So it's a full through penetration. No dampers are listed for a full penetration. A rated shaft would be the solution here. So unfortunately, dampers aren't enough to protect through 2 floors with wood construction. They're not going to limit the radiant heat transfer, so it's just the wrong application all the way. Most code officials usually will question this because on the installation page, they're not going to see wood construction associated with the curtain type fire damper, traditional 555 type. Then we have another misapplication. So this goes back to that wood joist floor system that I referred to. So this is what's known as an I-joist floor system. Fairly inexpensive, to build. So we obviously know why this is a choice as far as a specified floor system. It's inexpensive. It's typically seen in apartments, condos, more or less residential type. So the 2 things, the 2 major things wrong here is you have a floor system that's never been evaluated or allowed to have air duct penetration. So that's number 1. That's going to be the most critical. So it can't even be penetrated, period, with any damper product. There's no company that has a listing for any radiation dampers for these type of I-joist systems. Secondly, we have a radiation damper. Now, I will give them credit. They did at least choose the right type of damper, so they had the right thought process. But unfortunately, since the radiation damper hasn't been approved for this, on top of that, they have the damper close to the wood member. So you're going to have charring much faster because you have metal in close proximity to the wood. Even the approved radiation dampers in 2x4, 2x10 and 2x12 wood joist floor systems always have to have the blanket wrapped around the plenum boxes because in most instances you're going to have a plenum box up there. So this is wrong because of the floor system type and also because the damper is just not suitable to maintain adequate protection. So this example would be one where it's definitely a judgment call by the authorities having jurisdiction. We have little support for this because it's just not been evaluated and our dampers aren't even qualified to perform in this type of application. So this is, in fact, in this particular case, I'm not sure how they solved it, but this was just the initial information we were presented with. Okay, so before I get to the last slide there, I just wanted to cover some general questions and also give some answers to them, just to kind of sort out how you should understand, going forward in any of your applications. So we talked about the UL listing, UL qualifications. Well, there's also a company known as Warnock-Kersey. So Warnock-Kersey is another nationally recognized testing organization. So they do the same thing that UL does, it's just a different organization. So essentially, UL and Warnock-Kersey are two, UL being the most common or most prominent, but there are radiation dampers that have a Warnock-Kersey listing. Some jurisdictions, some code officials don't always prefer that particular product listing. They either like UL just because they're more familiar with them. They think they're a larger, more established company. So we do offer both the UL listed and a Warnock-Kersey product. We don't necessarily promote one over the other, but just from experience, I can tell you that the UL listed radiation damper for wood construction is a little more, or I should say it's easier to deal with that one because it's associated with specific designs, less confusion. It's not as generic as a Warnock-Kersey would be. So Warnock-Kersey has a little bit of a generic background to it. Warnock-Kersey was one of the first companies to do wood testing and wood truss assembly, so they sort of started it off, but UL is, in modern times has sort of taken that over and has elaborated on their testing much further. Another question that comes up is, are the CFDs, are they dynamic rated? We talk about dynamic rating, static rating on fire dampers, but for ceiling radiation dampers, they're not tested in heated airflow conditions. So they do not go through any kind of airflow or pressure test requirements. So we would say ceiling radiation dampers, they're not dynamic, they're only static rated. The UL standard itself assumes that there's no air movement. So in the event that you have a system where fans are going to continue running, if there's a fire event, most code officials would either, if they either are aware or not aware, most that are aware that the dynamic listing doesn't exist, they're going to expect to see a smoke detector to shut off the unit, just so they know that there's no air movement, at the time that a fire ensues. So just for the record, CFDs are static rated only, industry wide. Nobody has a tested dynamic ceiling radiation damper on the market. So just be aware anytime you're dealing with a fans-on application. Another question about plan reviewers and authorities having jurisdiction, right? Are they really coordinating between the floor and roof assemblies and the CFD testing? A small percentage are, but in general, most people have no clue really what they're looking at, even what they're seeing on the plans. A lot of times there's just not enough research or looking into it to associate what dampers are listed for what assemblies, and that's where the problems really start, because there's not enough analysis on what they're looking at on the plans. So yeah, very small percentage really do any coordinating. We know that just from the calls that we get, because the call we get is after the fact. And so now there's all this discrepancy. They're trying to figure out how to solve something. So clearly there was no initial understanding of what was going on. Another thing about mechanical engineers, when they're specifying CFDs, if you're specifying a ceiling radiation damper, if the roof ceiling or floor ceiling system's noted in the architectural plans, you can obviously check for that design number. You can check it out. You can see if it has a damper associated with it or not. Usually this is going to help solve a lot of problems up front. The more information, the more that can be figured out up front about the application, which damper type, or maybe there's no damper type. You may have to build a rated shaft, but any initial understanding of the design numbers that are specified, that's only going to help matters. So we would always promote that practice. Should contractors be insisting on getting the assembly numbers of the structure before they bid, if it's not documented in the contract documents? Absolutely. That's going to be another helpful measure, just to, if nothing else, just to help avoid the misapplication. A lot of times contractors are buying products before they really know the facts of the assemblies that they're applying them in, or if they even can be applied. So we're always trying to make people aware of the more information, the better up front. It usually avoids a lot of problems and holdups on the jobs. And the last thing is, should engineers be noting on these assembly numbers on the CFD schedule, in the spec? Absolutely. Anytime you have that type of information to put in there, it's going to just shorten the process of trying to figure out what can be done, what's right, wrong, whatever. So yes, we would definitely say that that's only helpful, because the first question we ask is the ceiling design number. Usually people don't know it up front. They have to go kind of research that out. So the more information shown on the schedules is only going to help. So we would absolutely promote that. So that essentially takes us through sort of a little summary of how to understand ceiling radiation dampers, the difference between the UL555C, CFD, as we call it, ceiling fire damper, versus standard UL555 fire dampers, which is thought of as a curtain type. Also understanding the design, UL design number, how to find it, where it's located on UL's directory. It's quick to look up, so it doesn't take a lot of time. Also understanding the horizontal assemblies and air duct penetrations, because as we talked through earlier, if you fully penetrate through a floor assembly, it's no longer a damper application. It turns usually into a rated shaft, unless you're dealing with some exceptions on the non-combustible floor systems. The limitation of wood assemblies and the authority having jurisdiction, obviously we covered that. Essentially that code officials are the ultimate end-all, be-all, final decider. Ruskin can only help present information, just to kind of give them some better understanding if they're not really versed in it. But the fire marshals, code officials, whoever holds that title will be the final one to decide what they'll allow in that application. And then the last point would be the CFD model, right? Which type should be used when and where. If you have a standard ceiling radiation damper that's not actually built or listed for wood construction, but you apply it in a wood ceiling, even though it's still a radiation damper, they're not all built identical. So that's one thing to keep in mind. So it does matter by the product model, because they do have different features between the wood type and the non-wood type. So that basically brings us to the close of this session. I'll stick around here for any questions. You can email in a question. I have my email address down on the screen there. If you want to, if there's any follow-up questions, if you have to depart the session. I do see some questions that have already came in, so I'll go ahead and look through those and we'll give some answers here. Okay, so one question we have is, what is the temperature rating of the fuse links? That's a good question. I didn't really get into that feature or detail per se, but CFD fuse links, 165 is 95% or more of the applications that we see. So 165 degree is the most common one that we apply on ceiling radiation dampers, and 212 is the highest limit link temperature that you can have on a ceiling radiation damper. So industry-wide, 165 or 212 are the two available fuse link temperatures. Another question, comparing 522 versus 545, has nothing to do with structural design of the dampers. Truss still must be made per truss structural requirements. Okay, so yeah, for the most part, these designs actually are very, very similar to the point of being identical. So they're really, it's little about the structural nature of it. It has more to do with insulation type, or if it's produced in a factory where they can do certain things that you can't do when you build them out in the field. So as far as the protection aspect of it with the radiation damper, when you're following the size criteria, because that's the most critical. If it says you can only have a 12 by 12 opening and somebody's trying to put a 12 by 14 or some other size, that's where it gets critical, because now the integrity level is hard to control once you exceed the opening size. So I would say in general, it has more to do with the opening that's going through the penetration, or the penetration opening, and then also how the damper is accommodated, because some dampers are required to have plenum boxes with blankets on them. So it's more about that than it is about the structural integrity, changing from design to design. So a question about, is the installation wrong because they cut through the floor joist? I think that's referring to the I-joist example that we talked about. Yeah, that's a little unusual too. I don't know that that's actually allowed in general, but the application of putting a damper in an air duct opening is I guess the bigger point, because that system's not been tested with air duct openings, period. So when you do it, you're just going beyond what's ever been evaluated. Question about is there a cheat sheet that helps us narrow down when to apply? I wouldn't say there's fully a cheat sheet. I mean, we can obviously develop one. We can produce something to help with that, but currently there's nothing that just has all this broken down easily, because a lot of it has to do with the ceiling and roof designs. We can't control what architects specify. So if it's a design that's unknown or one that's not even evaluated, there's not really a way to associate a damper for that. Let's see, one question. Okay, it was just a piece of information given here. Well, those are good questions that you are asking. If you have any other questions, if something comes up beyond this webinar session, you can certainly email us. We'll be happy to look at whatever the situation is. One thing I didn't talk about, but I'll bring it up because I was presented with it a couple of weeks ago. Somebody had a concrete floor slab, and they were trying to put ceiling radiation dampers in that application. Okay, two things there. A concrete floor slab would use a curtain type traditional UL 555 damper. That by code, that's what they expect, or that's the damper type that we would see there. So in a concrete floor slab, you do not apply ceiling fire dampers. There's not an installation for it. No damper company has a data sheet for it or installation sheet. So that would be a misapplication or just something that's not recognized. Radiation dampers are only used in lower membranes of floor and roof ceiling assemblies. Okay, the question about CFDs covered by the same ASHRAE temperature control as other rated dampers. I don't know positively. I would think yes, but I don't know that for a fact. I have to double check how that's addressed, or if it is or not. I mean, the radiation dampers are going to be obviously talked about in NFPA. We see radiation dampers dealt with there, the mechanical code and the International Building Code. So those standards or code requirements are going to deal with the radiation damper. I can tell you that more and more architects are sort of hearing about floor and roof ceiling designs, just an understanding of ones that are proprietary to one damper company versus the gypsum-owned designs, which have multiple damper companies. So our message to architects would be that, it serves you well to specify designs. I mean, if you're going to use a design that is just like another one, then choose the one that has less nuance to it, that opens it up to multiple damper companies. Because there's really no good reason from a cost perspective or benefit to the building owner to have a proprietary design. There's no good argument for that. And the last thing the building owner wants is a holdup on the job, because there's a discrepancy on which product can or can't be applied. So again, we're trying to solve holdups on the job, contractors that are sort of caught in the middle, code officials that may or may not know better on how to even understand this. Not all code officials came from the mechanical side. There's electricians or electrical inspectors that sort of moved over, so they're not always clear on certain applications. And we get that firsthand from them. So that's them telling us that. So it's about 3:15 Central Time. So the webinar is officially over, but I'll be standing by in case you have any other questions, or if you do have questions later, you can always email if you choose to. Do keep in mind that our webinars are posted on our website through YouTube videos. So we do have YouTube videos on the webinars. We also have videos on our wood truss and wood joist applications. So we have animations of how to install the dampers. So if you haven't seen those, you can go to YouTube and put in Ruskin, ceiling fire damper, just some kind of keyword, and it'll pull up our YouTube videos. There was a question about an AIA presentation geared for architects. We don't have one just at the moment, but there is a request for us to go to Columbus, Ohio for a life safety training at an architectural firm. So they do want credit for that. So we will submit something to try to get that recognized. So yes, there will be a life safety or CFD, ceiling radiation damper presentation, and other damper types that'll be sort of qualified for AIA acceptance. Yeah, once we get an approved AIA presentation through them, we will put out an announcement just so you're aware in case you have any architectural firms in your areas that we need to either present to and or do a webinar for or visit in person. So we can certainly arrange that. Okay, so I'll stand by for another 5 minutes before closing out this session. Again, we appreciate your time. Hopefully there was some information maybe that you didn't know about or was helpful in some way. Again, we can talk further on this if you have a need to do so, or if there's a current job or application that you're trying to work through. So just let us know. We'll be happy to assist with that or provide whatever information we can.